Hi, welcome to this new video where I'll be discussing optimization in video games. Okay, so optimization. The term is thrown around all over the place, calling out the latest AAA games as unoptimized pieces of junk or they suck. But what actually is optimization? Well, optimization is actually one of the latter stages of game development, where the developers begin to comb over the entirety of the game and sometimes its engine, so that things work smoother and run better for their intended hardware. But recently all games have been optimized messes. Aren't they just missing this stage out now, you might say? Well, the answer is no, of course not. But the thing that changes is who are the games being optimized for? And the answer at the minute is consoles. Consoles are a large game developer's main source of income, and so the main focus is the console hardware, which is completely fair and understandable because why wouldn't you focus on your most popular platform? But because of this, other consoles such as handhelds, PCs and Macs, etc. are often left way out of the optimization stage until last because some companies, and a particular one has been known to quote this, think that PC gamers can just throw in higher end hardware to make it run better, which is true, but why should we? Why should we have to do that because the developers didn't want to optimize for us? Well, this is because developers are still having to put more time and effort into optimizing for console hardware, which is static and doesn't change until the next iteration, and so that takes longer to optimize for, unlike the PC, where we're getting new graphic and processing hardware every few years. And this is especially true at the moment, whilst developers are still learning about the current gen PlayStation 4 and Xbox One hardware, and what it can run and what it can't. So, how can you optimize your games? What is usually optimized? How can you make it better? Well, many factors can cause the game to be optimized, such as code efficiency, polygon limits, post-processing effects, and many more, and I'm just going to explain a few of them here. Okay, so first up is compression. Compression in terms of compressed files that the game reads on. This can decrease performance of your game as the game needs to uncompress the files to use them, which can use up resources. It can also add processing overhead. However, compression is also good for your consumer, your audience, because of these smaller game files, and can slightly increase performance by compressing your textures, etc., so they take up less memory. A lot of games have also recently started shipping with uncompressed audio to increase performance and audio quality, because for an audio track you'd have to keep uncompressing it for every second of audio. Code efficiency. Code efficiency is an important one because it can help to reduce processor overhead to do simple actions. So if your code is large and complex, see if there are ways you can shorten this down or use procedures instead of repeating code, etc. This can help save some memory in RAM and again get rid of any processing overhead, which might not make too difference in just your everyday procedures and functions and a couple of other things, but if you did this in tons of code in your game and lots of procedures, lots of functions, etc., then it can increase performance boost significantly when looked at on an overhaul level. However, be sure to test your game for stability. Sometimes really efficient coding can cause programs to become unstable, which would then obviously defeat the objective of optimizing the code in the first place. Also, do remember that efficient coding can make expansion packs and add-ons easier to integrate and be more stable than if it was non-efficient coding. An example of this could be Fallout 3. That game was quite well optimized, however it was generally a little unstable on each platform, and sometimes the add-on packs, especially I think it was Point Lookout, could cause the game to become really unstable and often crash whilst playing that expansion pack. And then there's also the artistic side, so artistic optimization. The first one for this is rather simple and obvious, it's quite straightforward. Model your props and weapons so that they provide the most detail for the least amount of polygons and don't waste any parts on something that you're not actually going to see. A term most artists actually go by is, am I modeling for shape or detail? Because modeling for shape with large details is very important. That's how things should be modeled. Medium to small details are generally done in normal maps. Things like small wrinkles in clothing, screws, etc., they should all be normal mapped instead. Along with this is the compression of textures, materials and effects, which should take into account the user's hardware, because you don't want to have a very high large file size texture or all these fancy post-processing effects, which can be really taxing on the hardware, and then the user won't be able to play your game properly because these effects are mandatory, which is why you should have settings for your effects and model quality. Draw distance is a type of technical art. It's a type of art which is sort of integrated with the engine in terms of coding, so that's why it's called the term technical art. And this tells the engine or your game how close to the player an object must be before it is drawn onto the screen. So there'll be like a placeholder in your level, and once your character is within 100 meters of that, your barrel may spawn, instead of being there when your character is a mile away and they can't see. So obviously this increases performance and optimization by not having objects that you can't see being rendered in real time on the game, and instead just spawning them and rendering them when needed. And this obviously increases performance and memory usage, as it doesn't have to store the full detailed model in memory. The last I will mention is a technical art again, and that is LOD, or level of detail, which you have probably heard of. This is where you have multiple versions of the same object that has less and less polygons and texture maps and texture sizes for each level of detail. Generally, most games have at least 3 levels for each, or well, most props. Level 0, because most games languages are 0 indexed, which is where the first thing starts at 0, position 0. This is the highest poly. This is a model with the most polygons and the largest texture maps and the best looking materials. This is generally for things like first-person shooter weapons when you're holding it, cars, character models, all those sort of things. Things that need a lot of detail. Buildings, you know, very close by, using... It's sort of like draw distance again, but I'll get into that in just a moment. The next is level 1. This is a model which has an appropriate amount of polygons, which is mainly used for shape and, again, larger/medium details. This is generally for things like enemy weapons. These would probably have texture map sizes of 1024 by 1024 to 512 by 512, so that they have an appropriate amount of detail, but not too much that it's just wasted rendering performance. And the final is level 2. This would be very small texture maps of very small quality, and you know, we're generally thinking texture maps as well, probably about 512 by 512 and below. So this would generally make up the basic shape and nothing else, sometimes not even the basic shape. And this is used for distance rendering, crowd rendering, all that sort of stuff, where you're not really going to be able to focus on the detail of the object, and so putting in that detail would just be a waste. Unreal Engine 4 has the ability to change between these level of details depending on how much screen space they take up. I think it's actually put into percentage of a screen space. I will put up a screenshot here, video, and that's where you can find the level of detail. And speaking of level of detail, this reminds me of SpeedTree. So a lot of games use SpeedTree for their plants and trees, foliage, all that sort of stuff, because it's a great program for creating that. And SpeedTree is actually known for its included optimization. How it does this is it uses a 2D sprite for distance viewing, and then it turns this sprite so it's always facing the camera. This means that only a simple image plane is being rendered, but the player sees a tree, or a plant, or foliage. And so when this is in the distance of like a forest, this looks really good, and it looks really complex. However, it's simply just a load of planes with an image stuck onto them. So it makes the world look great even in the distance. So that's optimization. That's some ways you can optimize your game. So what are the pros and cons of optimization, just to wrap this up? Well, the pros are obviously it's a more efficiently resourced game, which is great, and your game overall performs better, which means you get better reviews by those who play it, because like, this is great, it runs smooth, you know, I would play it again, which is what you want. And because of how well it runs, it means you can get a larger audience, because if it's optimized correctly, it should work on slightly lower level hardware than you intend to as well. And obviously efficient coding and optimized games allows for easier porting, because most of the bulk work is already done. So if you decided to port from, for example, PC to a console, and you've optimized your game and efficiently coded it, then you just have to change it a little bit more to match that hardware, however you won't need to do too much. And obviously, like I said before, it just makes it easier to add on content and expansions without breaking your game, which wouldn't be very great. So the last is the cons. What are the cons of optimization? The cons are pretty straightforward. You know, it's costly. It's costly in both money and development time, because it's quite a big stage, especially for large games. The bigger your games get, the larger this process takes. You can optimize your things before even importing them into the game engine, but again, that just means it takes time and time whilst putting the game together. So you should really do it in all the stages. Optimize your models before you put them into the game, so that you don't have to optimize them later on. Optimize your code when coding it, but obviously make sure the game works in the first place instead of wasting time and effort trying to make an efficient way of coding if you know another way already works. So again, this can also introduce a new amount of bugs, because obviously the more efficient the coding is, the more generally you can run into bugs. Like I said, your game can become unstable because you're so focused on making everything small and compact that generally you might miss out a few things. And finally, each platform has to be individually optimized for. Like I mentioned before, if you went from PC to console, you're going to have to re-optimize your game a little bit more. If you went from that to handheld to mobile, from console to PC, from handheld to console, each one has its own optimizations, its own processors, its own graphics cards that have to be taken into account when being optimized for. This is why generally console games do look very similar. Some games do look better on other consoles and on that, because they're individually optimized for, but a lot of the time they generally optimize it in terms of this is how it looks on both the consoles, and then if you put it on PC, you can generally throw in all the artistic and technical effects you want. So I hope you enjoyed this video. I hope it clears up some things of what optimization in terms of video games is. If you like this video, give it a thumbs up. If you didn't, give it a thumbs down. If you have any suggestions, questions, advice, or you just want to leave a general comment that you enjoyed the video, leave it in the comments down below and I'll get back to you as soon as possible. Don't forget you can follow me on Twitter at sam_ba_jones97. There's a playlist popping up in the corner, check that out. That's some of my tutorials, which you may enjoy, or there's also the discussion one, which is C++ versus Unreal 4's blueprints. And as always, don't forget to subscribe if you want to see more. Thanks guys, bye.